Hey everybody, this is Larry. This is me going Q4 of the Biweekly Contest 87, minimum money required before transactions. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this form. So you can see from here that I struggled a lot for this one. I spent an hour about it and 3 correct attempts. We'll go over my logic as well a little bit. So yeah. First things first is that this is a greedy problem. For a greedy problem, the hard part for me is just sometimes proving that it is correct and also that it's sufficient, right? What I mean by that is that this is one of those problems where, there are multiple conditionals, and I don't know that, like let's say you need A, B, and C. For me, it is hard to figure out why D isn't necessary, right? So that's basically the hard part. But there are 2 solutions to this that I'm aware of. Maybe or like 2 general strategies, not only solutions. One is that the way that I did it, which is very funky. And we'll go over that first. And then second part, and you can maybe skip ahead if you like, is that I'm going to try to live solve the actual straightforward greedy solution. So yeah. So first of all, the way that I did it is with binary search. The thought process here is that we can binary search on the answer. Let's say we have, say, $10. If we knew the exact transaction to the order of the transaction, then let's say we knew the exact order of transaction, then we should be able to go just like, just do 10 and then go left, from left to right, and then see if it fits, try for every number. So that's the way that I did it here. That's what the logic is here, right? So this is the binary search. This is, this is the binary search. This is the binary search bounds. I'm not going to go over binary search in this video just because, this is a Q4, so I'm going to keep this a little bit within, like assuming that you already know how to binary search. And here it's just going from left to right. This is a straightforward thing. However, the tricky part is that we have to do the ordering, right? And this is the ordering that I came up with. To be honest, as when I submit this and got an AC, I actually wasn't able to prove this. I actually spent a long time. Okay, well, I guess it doesn't show. How do I show this? Sorry, friends, hang on a second. I want to see like how much time I took. But the short answer is that I took a lot of time on this between submissions. Because I got this, okay, yeah. So I got this like maybe not very quickly, but got the general idea very quickly. And then I spent about almost 50 minutes resolving it, right? So that's the part. So there are a couple of ways you can sort, and my first instinct, to be honest, is to sort by the cost minus cashback, because that's how much it would cost, right? And in a greedy way, I thought that you could just, you want the cost to be the greatest, and minimize the cashback so that it maximize like the realness, right? One visualization that I was kind of hinted at, and I was thinking about this during the contest, but not able to really, like I have the idea, but I wasn't able to articulate it into action. Is that basically you can think about this as a number line, right? And you on the x-axis you have like transactions, so processing like how much money I have, right? So let's say you start at some X amount. And then you add some costs. Let me just use it right. You subtract some costs, and then you add some cash back, right? So then here, so the idea here, of course, is to see if in a greedy way we can get this line to below 0 before the cash back. So then here we can adjust, and if you draw this out, right, and then at a certain point you might have. Some might, and then something like this might back up to 0 or back higher than 0, or maybe not, it doesn't, something like this. So then here, then this would be your starting amount, right? That's basically the idea. Yeah. So that's basically the idea, maybe with a terrible drawing. But, and another way to think about this, and I drew this in a very exaggerated way because, oh, why am I drawing with the mouse? I was wondering why things feel so weird. I forgot that everything. But yeah, but basically this is cost, this is cash back, this is cost, this is cash back, right? So another way to kind of think about this, of course, is just by doing cost minus cash back, like we said, right? So you can have you can have something like this, and then the idea here then, right, would be that you start at some number, you have negative slope, you have negative, you have negative, you have negative, you have negative, and then now maybe positive again, right? So same idea, but different drawing or visualization. Okay. So I was trying to figure out a way to calculate that, but instead I came up with the exchange argument, and this is something that maybe you can Google in as well. But the problem with the exchange, or not problem with the exchange argument, but my problem with the exchange argument for this problem is that it's not, the way that I wrote it was not transitive, and I'll go over this in a second. Basically, I go, okay, like in a greedy way, or maybe not a greedy way, but just calculating, right? If A is first, what am I doing here? If A is first, what is the amount needed, right, to start? And this is basically because now we have two elements. We can let me see my blocking the screen real quick. Yeah, we have two elements. Then you can kind of just go through the scenarios, and that's what I did. I go, okay. Let's say I have this case, right? And let's say A is equal to this, something like this, right? Well, if A is first, how much do we need? Well, then the answer is going to be 3, right? Because if you start with 3, then sorry, let me sneeze real quick. Sorry, friends, live recording. Okay. So yeah, so you could figure out why, but yeah, let's say we start at 3, you do A and then you do B, then it is then it is sufficient. And then the other way is if you start with B and then you start with A, how much do you need, right? Actually, did I say 3? No, I was wrong. So you need if it's A and then B, you need 5, right? Because if you start with 5, then now after this transaction will be 4, and then you get this to be done. And then the other case is just if B is first, then you only need to start with 4, right? So then in this way, I go, okay, because this is 4, B needed is 4 if B is first, and 5 if A is first. So then let's put A first. That's the idea. There is so that's how I get this part of the formula. But the idea is that, well, let's say you have, let's say the same, but then now this is 100, right? Well, in this case, you need, or maybe another thing is like something like this, right? In either case, no matter where you start, you still need 100, right? So that's basically the idea behind here, is that you need 100 to kind of, you need the maximum to so that you could clear one of the hurdles. So this is the part that I ran into an issue with, is that this is not transitive, right? What I mean by transitive is that if A is greater than B and B is greater than C, then A is greater than C. Because the problem is that in this case, in something like this, both A needed and B needed are both 100, so they're both equal. So initially I was returning 0 here, meaning that they're equal, but that's not true, because you can imagine another element, like for example, I'm just making this up on the spot, so this is a little bit tricky. Let's say this is, I don't know, 4, 2, right? Something like this maybe. in this case, or even 40, say, right? Let's say 60. Okay. In this case, you could A compared to B. You know, this A needed, B needed is going to be 100. This thing is also going to be 100. So then now it thinks that A is equal to B and B is equal to C. Therefore, A is equal to C, right? So that's the other part of the transitive thing that I actually left out. But it's not true, because if you compare this number and this number, well, we need 6. Maybe I messed up here on the let's say this, right? No, then I messed up, I think. But okay, let's go back to the original numbers then. But the idea is that, okay, let's say, you know, in this case, like I said, A and B will be count as equal. B and C will be equal. But then A and C, well, we know that there's an ordering because that's one of the things that we did earlier, right? So what breaks this tie is, well, just optimizing for cost. That's basically what I end up doing and YOLOing on. And after this sorting, everything fell into place and everything's good. I'm not super happy about this, to be honest, so that's why I'm going to do a bonus solve on the other solution. Anyway, let me go over the complexity really quick. This sorting is going to be n log n. The binary search is going to be n log r, where r is the range of the numbers. So yeah, so that's basically the complexity, and so the total time is going to be n log n plus n log r time, and space is just linear, right? Because you're sorting. That's basically one way of doing it, and it took me an hour to figure that out. And even then, like I said, it's not the optimal solution, but sometimes, especially on the contest mode, you rather just have, you know, a bad solution that is accepted is, you know, good enough. So yeah. So the other way that I'm going to try to think about it is, so I did, if you watch me try to solve this live for an hour, you'll actually, oh, let me actually do it here, because, I don't know, in contest, whatever, it looks a little weird. So basically the way, I actually, you know, there are a lot of observations that you can make. For me, I just wasn't sure that that was sufficient. So let's, you know, thinking about the visualization, the drawing that we did, let's make some observation, right? It's that if cost is less than or equal to cash back, we don't care for the most part. We'll talk about this in a second, right? Because this leads to a better result other than the initial cost, right? So yeah, so let's think about this. What does this mean, right? So let's just say best is equal to 0, and then for cost or for cost, what's it, cash back in transactions, best is equal to max of best cost. There's no way around it. You just need, you know, like, you can't really do better than that, right? And then now, the second observation that I also made on contest, as you see, is that you want, for the ones that are remaining, we want to be greedy, right? So yeah, so then now first we filter it out. So transaction is equal to cost cash back for cost cash back in transactions if cost is greater than cash back, right? So then now we filter the other ones out, and then we go, and now what does that mean? Well, now we can sort by well, we want to sort by cash minus cost, cash back, right? Cost minus cash back. And the idea here is that that you know, you look at the slope, we want to greedily pick the one that goes down the most, right? And actually I did it in the wrong way by accident, because this sorts minimum. Okay, fine, let's do it the other way, and then we do reverse as equal to true. Maybe that's a little bit cleaner, because now we want to sort by the one that slopes the most way down, right? And I think that that's maybe mostly it. Is that now we can work our way back. One additional observation is that you can how do I say this? That I think we can choose one cashback to ignore, right? What do I mean by that? It means that if you put one of the cashback at the very end, then you can ignore it, because after the last one, let's say we already filtered out the one that gives you more money. After the last one, you're gonna have always gonna be positive. So the last moment where you care is the one except for the last cash back. So then here we can do a for loop to calculate that, I think. So okay, so let's see. So the way that I might have it is, so delta is equal to cost minus cashback. So this is the cost, right? So then let's say we have total cost or total delta is equal to 0, and then total delta we increment this by, I guess, this amount, right? And then now, so that's how much stuff you have to begin if you have all the cashbacks. So now we can choose one cashback to ignore. And to be honest, I don't know if this, I think this is, I think the tricky part now is knowing that, I still don't know if this is right, which is part of the hard part of the greedy problem, to be honest. Okay, so delta is equal to cashback, total, so total delta minus delta, but we want to add in the cost. It's going to be the highest we have to do. So that's basically the idea, right? Am I missing a case, to be honest? So that's based, let me see, right? So we could ignore one cashback. Yeah, I think, oh, let me give a submit. To be honest, even though this is an explanation video, I am doing a little bit of a live solving. And this also points to the fact that how hard this problem is, greedy-wise, right? In terms of proofs. Like, obviously, we wrote it, we could submit it, we could YOLO it, but how confident am I? I don't know, not very confident still, honestly. So let's give it a quick submit, and then we'll see. I'm not, okay. Yeah, I was gonna say I'm not surprised either way, so I've definitely missed a case then, right? And that's part of why it took me so long, was that I couldn't prove to myself that something like this was good enough. You have to make one more observation. So I put 15 when this could be 18. Okay, let's see. All right, let's print out the transaction for debugging. Okay, so these are the only ones that we care about. Maybe, yeah, okay. And here, luckily, we have a easy thing to or not easy thing to debug, a easy thing to work out. So this is the sorted that we have, and here we can do it with 15. Why? We start 15, we go to 10, then yeah, this is good. But we think that it should be 18. Dun, dun, dun. Because here, and I don't think we need to care about the other elements. Yeah. So then here, why is it 18? Let's say we have 18 and we start with the 5. So now I have 13. Let me try to find. And also this is, of course, having the solution versus during the contest, obviously I have to work it out manually. But here I'm a little bit lazy, and in interest of time, we can take a look. Oh, that's right, huh? What is the example that? Guess I could just try it all the way. Okay, well. Wait. Oh, this is the exact sample that we had earlier, right? Maybe? Oh, wait. Huh. So why is this returning 18? Let me see. Did I mess it up? So the total delta is going to be 10, 13, right? Total delta is 13. We can ignore this cash back. We have 15. Why is it 18? Did I throw away something by accident? Maybe I missed the logic then. Let's say we start at 4, and we're 15, 15 with 10, and then that's way too good. Huh. Let's see if, maybe I had an assumption on this. Yeah, maybe this video would take another hour. But yeah. Okay, so I wasn't wrong here. So this one is good. So I made a wrong assumption a little bit on filtering these out. On the ones that I filter out, which is 5.8, 5.9, and 0.10. How can they change the result? Oh, because you have to end with at least 5. Because I was assuming that because it goes positive, you don't have to end at 5. But we have to actually end at least 5. So then now for the ones that we do filter out, for the ones that we filter out, it has to end at least the most cost. I thought that this would handle it, to be honest, but yeah, basically you have two components, right? One that we don't care about, but we have to start. Okay. But this points to how tricky these greedy problems are, right? Because I wasn't even able to figure it out. And also, like, let's say I do, I looked at this debugging as we did, and we solved it, right? We figured it out. How do I now know that this is sufficient, right? Like, okay, I know that I solved a wrong answer, but is it enough to add this if statement type thing, right? So, okay. So we'll start, say, is equal to max of cost for cost cash back in transactions if cost is, yeah, so on the numbers that we filter out, right? And then now, so here, this is the total delta. So then now we have to add this to the worst start. Yeah. Oops. Huh. Is the default is equal to 0, right? Something like this. I think there's a max. I think I have to convert this to a list as well. That's right. That's more. Okay. So this is still wrong because now I put 20 instead. Why? Oh. It's because first start is a 5, but we end this. The math is hard. Let me think about this for a second as well, because I just added 5 lazily, so it went from 15 to 20 as the answer. But what we want is that if we subtract this, what we get is having a 3 in the answer, right? So, and that's part of the cash back. So it's going to be worst start minus cash back. but it has to have like a min of 0 or something like this. Yeah. What did I get? Well, now I'm getting a lot of things. Well, tell me why that. So the worst start is gonna be. Oh. This is max, not min. Min. Whoops. Okay. Like I said, right? Like this gives us not accepted yet, but code that looks okay. I'm gonna YOLO submit, but like I said again, I don't know. I'm not that confident that this is good enough, right? Especially during contests. I have a little bit confidence only because, I this is after the contest, so I reviewed the answer a little bit, but I don't know that this is sufficient, right? And having this answer, like even after getting the accepted, I'm still not that confident. That's how not confident I am about the solution because I don't know that this is all there is. Um, that said, I think if you break it into two parts, the before part and the end part, maybe that's another way of thinking about it. Meaning that you have the part where everything slopes down, everything where this slopes up, but you have to take account the initial cost. I think maybe that's exhaustive, but that's still a way. Like you really have to do enough problems, and I've done a lot of problems, but still a little bit bad today on this problem to kind of to really be confident about it. So yeah. What is this? This is n log n because of this sorting. Otherwise, everything is just linear, like it's just max and for loops. But let me know what you think. Let me know how you did. Let me know what you think about this problem and explanation. I know that this probably isn't the best one. I always mention this, right? Greedy problems are really hard for me for this reason. And it's not that like, okay, like if you look at the solution, then maybe like, oh, I could kind of prove this, right? And maybe you can. But then the idea is how do you replicate that in a future contest or in interviews where you're like, okay, like I said, you have conditions A, B, and C. Do I need to make one more observation for this greedy to work, right? Like, do I have to do like a weird sorting thing to make it, like an additional sorting thing to make it like, okay, just right, right? And is that enough? For me, I don't know that, that's the tricky part for me. Anyway, that's all I have with this one. Let me know what you think. And you can watch me solve it live in the contest now. Okay, that wasn't that bad. That was actually not pretty bad. I mean, it is a problem. I don't know if a lot of people got it though, so maybe it was just me, or maybe there's a easier way. I don't know if my way is the way I prefer, because even I struggle with it. Okay, anyway, Q4 minimum money required before transaction. What does that mean? In some order. In order, that's all. After money. Cash back. Let's see. Is there an optimal way to vote this? So do we sort by cost minus cash back? I think probably. What do we want to do? We want cost minus cash back because then it's the most costly to do this one, right? So yeah, something like that. And then now we could just binary search, right? If this is true. Okay, let's try that. Let's just say 20 to be safe. I don't know. Maybe too safe and maybe too slow. But you could probably maybe even, I don't know if this is true. If we can solve it using the mid, then we want a smaller number. And then Okay, this is if we can solve it using this target, and then this is just for the cost, cashback in transactions. Current is 0 to target. Okay, so make sure. If current is less than cost, then we return false. Nope, the other way around. That's not right at all. It should be in any order. So why is this working for 0? Cost for 0. It should already be false unless my sorted, that's sorted the other way. Let's see. Maybe I just wrote the wrong way. 0, 3. Oh, I did. Because we want the most cost first, right? Why did I do it this way, huh? Whoopsie daisies. Okay, 9 and 3. Did I mess up my binary search? 3 seems okay. Why is 9 okay? Let's see. Maybe I misunderstood the problem. A lot of people seem to have gotten it, and also kind of quickly, to be honest. Maybe not. I don't know. So it thinks 9 is true. Why? Tell me why. Maybe I saw this one. Okay, let's see. So you have 9, it goes, and 2. Okay, that seems right, but assuming that my logic is right. Oh, I see. Because if I do a 5, if I have 9, I have 4. No. If I have 9, I cost 5, I have $4. And then here, I do 2, and I add 1, I have $3 left. And then this is wrong. Huh. I thought that this would be right. This is why greedy problems are so hard. Huh. To be honest, did not expect this. So, what makes it good? I'm trying to think about the properties that make this good for 9 that isn't the case for the other direction. So you have 4, you have 2, and then you have 4, and then you use 2. So then now this is now 3. Even though this is -2 on the 4, this is, wow, why is this, well, that's wrong. I sort by cashback. This feels like a YOLO though, to be honest. Like if I sort by cashback, is that good? Nope, even worse. Why did I get rid of the print? Oh, did I just have a typo? I think I have a typo. Whoops. Is that good enough? I mean, it may be right. I just don't know the proof. Is the proof YOLO? Why is it that you can't close the... I'm going to YOLO just because I have no idea. I'm not confident about this at all, though. Okay. Where's my print statement? I don't know how to do this. I don't think. Though a lot of people got this. Oh no, wait. Maybe I lied. Okay, some people got this. It's gettable. I'm 112. Okay, so this is just sorted by... Why is 21 okay, not 24? What is the worst case here? Huh. Because I think figuring out what to greedy on is allows us to binary searchable. But 21 clearly, if we sort by cash back, why? Unless you do binary search on all three and then just greedy, but now that doesn't make sense. There's some local things. Huh. I don't know that I know how to solve this one, but a lot of people did, I guess. Huh, wow. Actually kind of impressed. N is 10 to the 5th, so I don't think there's any DP solutions. Well, it's not I would have thought that this works, but what is it about having 2 and 1 first if it's not the cash back? 9. Okay, let's reduce this a little bit then, because this clearly doesn't matter. Though I should still have it as an input, I guess, for later. So what makes this answer 4? But if you did it the other way, 4, it goes to 2, and then you get 1 back in it. So that's not good. Is there some exchange principle? What is the exchange principle for this one? I forgot how to write it too. It's like now sort by comparison. It's like I forget how to write it in Python. Not gonna lie. Okay, because I know I only forgot about it because I know that's something ridiculous, but let's just say compare and then you okay. Basically is saying if I do this first, then I need the cash back. So then it is how do I express this more precisely? So okay, so if I do 2 1 1 2, then the idea is that
maybe I could just simulate it. Maybe I don't need to be that confusing. But if I have 0, then it would cost go -2 plus 1 is -1, and then the delta is 5, right? So maybe it's something like a sub 0 minus a sub 0 plus a sub 1 minus b sub 0. We compare that to, how do I write this comparator again? So we compare this to something like that. Well, these three are right, but this one is really wrong. So, It may be that this isn't, maybe I'm missing something to also I'm sure that this kind of reduced some stuff. I think this reduced by sorting to by the other one, but can't really prove it. I don't know that this is stable as well, so that maybe that's why this is giving me issues. But now this is just seems like it's sorting by thingy, by the cash back, which is what I did anyway. Though except for now is a much weirder way. Still maybe the exchange principle, but maybe I wrote it in a weird way. So basically, requirement of this would be 5. Can I do a binary search on the exchange principle? Figure out the answer to this? Maybe, but that's just ridiculous, right? We can just work it out backwards. So the requirement of this before this is going to be okay, so 4, we get 3. This is 5, right? So it's just b sub 0 minus this, but this is just subtract of whatever we had here. Yeah, I think this is just the inverse of what I had, so that doesn't make sense. How much time do I have left? Because I didn't start at a reasonable. Oops. 54 minutes, huh? So I have time. I just don't know how to do it. Kind of disheartening that 18,000 or 1,800 people solved this. But the exchange does goes to the other one, but then it's just clearly not right, especially this one. But it just means that it's not transitive, or it's probably not transitive, or at least the tie breaking isn't sensitive, because I think it compares some stuff to equal. because I guess this and this. Is this stable? Maybe, maybe not. What is the ordering? Again, why is the 2142 case so weird? I thought I could just greet on the other thing, but And why is this really wrong? Yeah, it's the other way. Whoops. Maybe I'm wrong on that one. Maybe it doesn't matter. I actually did wanted the 8 to go before the 0, but maybe that doesn't matter. Well, it does clearly matter somewhere. No, do you? I mean, it does reduce this and then just this. But then this is wrong for this case. Why do I keep taking up the point? I haven't solved it yet. Which case is wrong here? That gives me the more. You always want the cost first with the benefits last, but man, not getting that Q3 quickly kind of bite me in the butt. Also one wrong answer. Is there an easier way to do Q3? Apparently. Well, clearly you want to do all the ones first. Can I do induction on that? Why? What is wrong with this one? But do you always want these cashback ones? Clearly not, because this is showing me the wrong answer. How did I get an answer that's slightly wrong in the same idea? Well, this seems clearly wrong. Oh, no. It's cashback. I got them wrong, the wrong idea. Okay, this is clearly right. And what is the case that I'm looking for? Something that costs a lot. Have something like this. Yeah, 9 first. But what if I have a 6 here? Oh no, wait, the other way. What if I have a 6 here? Do I still want the 9 first? Now it's going to be a 7 because now clearly you still want this one first because then the 7 will not pass. So what's special about this one? It's still the exchange principle, maybe. Maybe I'm just not doing it right. Doing it right. Oh, I didn't do it right the first time. Let's see. Okay, I mean, it's good that we have a case that's clearly wrong. Okay, so how do we figure it out? Well, if we do this one first, what do we need? We need 3, 4, well, we need 7, I guess. That's why we have 7. So we have 7, and then here, the other way, we need a 9, 6, and yeah, just a 7 and a 9. Maybe I just need it to be more intricate. Okay, so if okay, A, let's just write it out. A first. So then here we have the needed is equal to A sub 0 first, and then either that you have A sub 0. Let's say you start A sub 0 money. You spend it. So now and then you get cash back. And then so is there only 2 numbers where this suffice? No, there's more. Even in this case, okay, how do I get 7? Right? Okay, you start at 3. Okay, let's say you do it in this order. And my brain is not very functional. So it's negative 3 plus 5 is 2, and then you have 7, right? So let's say we do it this way. So A first we have B1, B0 minus A Z. No, it's plus minus A1, but it's also something like, so it's either this or A0 in general. So A needed maybe. And then it's the other way around for so if we needed A more, then we return -1 because A is better. I always return 1. Did I mess up how to write this? Oh, whoops. Okay, now it's right, but I guess I just didn't write the formula quite right the first time. Let's try it again. After taking out the print statement. A big wrong answer is pretty tough. Got a little bit closer though. Does it tell you how many? Okay. Huh. Wow, I don't know that I know how to do this one. Yikes. And you have all these cases where the cashback doesn't really matter, does it? No. So this is a little bit better, but am I missing a case in my sorting? Thing is, I don't know how to get the best answer from this. If not, or rather, I don't know how to find a smaller case in which this is wrong. I guess we can brute force this. 42 minutes. Okay. What is this n? So we can't really do n factorial. Huh. Well, that's rolling. Well, So I think it's 260, but there's a case in which you can sort this such that it takes 290. Okay. If I slowly take out numbers, doesn't matter. Like the 94, 94, that doesn't seem very helpful, but maybe my assumption is wrong on that one. It is, in fact. That does come into play. Why does that increase by 4 or by 3? Oh, my answer. I don't know what the right answer is now, so. I guess it's just that the string is less than 94, so okay. Maybe we don't take that out then. But we should be able to take out a 62, right? Still get the same wrong answer. What? It should not be the case that you take out a number and get... The more constrained should always have a worse number, right? So that's just weird. I see. So this sorting is not stable. That's the problem. So here you see that you have this thing, but once you take out the 62, it's sorted the other way. So that's why. It's either that or it's just not stable. Meaning that it thinks that these are the same, but they're not. Maybe. This thing is 94. I'm also very tired. Maybe I should have done this tomorrow instead. This thing is 104, which lies to. So that means that the way that we did the exchange argument is it's a bit incorrect, because it's either that or things they're equal. Maybe that's why. Let's see. Yeah, because it thinks that they're equal for the other ones. That's why. So then it just assumed through the transitive property that they were equal We can't really do an n square sort, so that means that this sorting right now is not stable. Well, not that stable means something else. Sorry, it means that it's not transitive. So the transitive probably doesn't hold. So then you can't really sort by this. Huh? How do you do it? Why is this different from? Oh, because it gets dominated by the 91. But if you look at it directly, it does not any longer get dominated by 91. Huh. So it's not the exchange principle. Wow. Or at least not quite like this. Both need 94. Both need 91. But you put them together and you need more. Because this thing. Wow, I really don't know how to do this one. Am I wrong on the sorting? Is there any other cool way of doing it? Okay, given target a map, is there any way I can just look at? Okay. Let's say I have 7, right? Take the biggest, that's 5, and then it fails. Can I do n log square n? I think maybe too slow. I just want the cost. No, because one of the higher costs could give like a huge number back, right? In fact, the 2-1 is the one that failed, because if we do the 4 first, it only requires 4, and then if we do the 2 first, it requires 5. But can we also just... Huh. There must be an easier one than this, but way of thinking about it. Man, I am not solving this. Yikes. can I have a number and then try to find the worst every time? Max is definitely awkward though, but it's still, if I do it this way, it would be wrong as well. Am I stuck in a way? Can I figure out a better way of doing it? Okay, let's say I have $4. If I do a search on this, I would just have. I don't know how I can. Let's say I have $4. Is it just here we need 3, something like that maybe? I'm just playing around with different things. I don't even know if this is true, to be honest. No, that's not really right, is it? So at least it's consistent now, which is good, but very wrong, which is not so good. Oh, this was probably right, but why is this only 2? Oh, because it goes into 2 and then Why is this one so weird though? Okay, well, but still wrong. I was hoping, just trying to see. I'm running out of ideas, to be honest. Because I'm good that I missed the fight on this one. I mean, I don't even have any ideas to play with now, to be honest. Otherwise, I would try different things. I mean, I have some wrong cases, but I just don't even know how they apply. So this one we know, and then we have these 3 where we know that it cannot be, they're not transitive. But then how would you sort them in a good way? Wait. Can we throw away any transactions? Well, the one that gives you money, like net positive, you never want to do anyway. But I don't think that's the issue that we're facing, so I don't think that matters. Well, that's not true per se, because you can imagine like a big number and you still need a big number to start off. This is definitely 104 though, or something like that. Yeah. have no idea. And the numbers don't have to be one of the inputs. Oh, Is it something silly like only one number doesn't, only one cashback doesn't matter? If that's the case, that'll be very sad. I don't know what I'm doing. And if the only one cashback doesn't matter, and you want the biggest cashback, right? That doesn't give me the answer though, does it? Does the order still does the order matter? I'm just so confused right now. Okay. Well, is it true that no? Well, okay. So only one cashback doesn't matter. Maybe that's another observation. How do I use that observation, right? Meaning that that transaction is the last one. Can I brute force on that? And so then it's 4 minus this. How much time do I have left? 25 minutes. Well, might as well give it a try then. Okay, what would that look like? Well, you just sum up the total, so then 4, it would be, wait, no, oops. I guess we just do this. What am I doing? So we just sum up all the previous deltas minus this. Okay, let's just see. Right. And then now the current delta is back. So then we have delta minus the current delta plus cost. That's not quite right. Obviously, but so this is, well, let's print some stuff out. Maybe I just some signs. Well, I'm just trying different things, to be honest. I don't know that I have any idea here. Okay, so the delta, this is wrong. This is -1 and -2, so this should be, okay, so delta is -3. That's correct, actually. So then now we want to subtract one of the deltas. So I'm going to subtract this delta. So then we have -1, and then we have -1. plus TC. No, plus cost. -1. And I get 3. Maybe my signs are wrong. We have -3. Yeah, maybe something like this. Maybe delta is always negative. Well, that's not true. I'm really weird. Okay, it finally fixed this one, and but not the other one, so it's not very helpful. I don't even remember what I'm doing with these other problems anymore, so that's also a problem. Okay, so for this one, it thinks it's 9. Is that true? Yeah, it should be true. But definitely, we got these two correct, but not these two. I think it's like 270, something like this. Maybe that doesn't really work, because also this is not 9. I think this is 27 or 24. I think 24. What I think is 9 though. So maybe the order still matters, and I'm not being helpful that much. Okay, 1 cashback does not matter. But what does that mean? What can I do to solve this? 1 cashback doesn't matter. But if we sort by cashback, I guess that's essentially what we're doing if we try to do greedy. So we already had that previously. Wow, maybe I just don't know how to do this one. I've been struggling on this one for a while. A lot of people have gotten it. People got it in 2 minutes. Okay, so maybe that observation doesn't do anything. Though it did finally get these two, but even this one is not just, well, yeah, maybe not, but because you have all these 0.9s, but you have positive delta ones, and that's why it's a little bit awkward, because it cancels out the impact even though it shouldn't. Oh no, the other way. I mixed up the numbers again, but nonetheless. But you have this 0.9, 0.4, and it's canceling out the impact too much. Why? How does this? Okay, so let's say we do sort by whatever. Can I brute force not doing one of them? N times. No, that's too many, right? That's n squared log n. No, that can't be. iframe. Wow. Maybe I shouldn't beat that. Oops. Is there any other observations I can make? How many comparisons are there? Can I do binary search and order comparisons? No, because there's some like weird, and you can't really. Do a stable n square sort. Huh, what am I missing? Sad Larry. The reason this is wrong is because of these two, which is yeah. That doesn't change anything though. I mean, I may get a little bit luckier, but yeah, better lucky than good. It's gonna give me a wrong answer on something big, I guess. Time limit exceeded? Did I have a print statement that I forgot? That is actually not one of the things I considered. It's just sorting. Why is it? Oh, What is the answer on this one? Okay. So I guess we don't need this to be that big, so. Oh wait, this is 10 to the 9, right? So there's no way that'll be definitely too small. 10 to the 13 maybe. Spare some cycles. What is it? 10 to the 9, 10, 5th, so actually probably like 15. Spare me like 20 loops or so. Or something like that. Maybe not. Maybe the server is just not consistent and giving me the timing. Oops. Alright, let's give it a YOLO submit. I mean, it's not a wrong answer at least. But I might get another time limit exceeded. I thought I had this. Oh, I guess I didn't do the tie breaking. I didn't get the equal case. So what I did was if they're equal, I make the cost more one goes first. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. And yeah, I'll see you later. Stay good, stay healthy, to good mental health. Goodbye and take care.